Square roots are something difficult to understand at the very beginning when they're given to somebody because it's a different symbol and a different idea. So often we're given this symbol here and the number in it, and we're told, find the square root, right? If we go back and look at, other simple arithmetic, we can say, multiply, right? So we have 2 times 3 equals 6, right? So this symbol here means multiply. When we see that, we automatically recognize multiplication, or when we have 2.3, the dot means multiplication, and addition is plus, etc., etc. So the symbol for square root, right, is this. This is the symbol, right? This is the symbol, and that tells us what to do to the number, right? So when we have the square root of a number, right, we want to find an answer to that. That's an operation. So what does that mean? Well, we are looking for a number, right, an unknown number to put into this box, square it, and get 4, right? So that would be the root, right? This would be the originator, this number here, that we don't know, question mark, that's a question mark. That number there squared will give us 4. So that's what we're looking for. What is the root? What number did we square to get 4? To find this answer, right? To find the answer of what number did we square to get 4, we use square root. That's the operation. That's like an order. We're told find the square root. Immediately we're going to answer the question, what number did we square to get 4? And for us this is very simple, so we can say 2, because 2 squared equals 4, right? So that's the answer. 2 is the root. Is the root that when squared gives us 4, or 4 here, anywhere. That's the concept behind the square root itself. It's what do we do, what do we do to find the square root? We answer the question, what number do we square to get the number under the square root, right? So that's pretty much what the square root is. Now there might be complicated square roots, like let's say square root of 16. Well, I'm going to complicate it just to show how I'm going to go about to find the square root of 16 if I don't know the immediate answer. So what I'm going to do now is I'm going to find numbers, right? I'm going to find numbers that are going to end up being like this, numbers that be like this, because the only way to get out of the square root, right, is if you have that little 2 up here. If you're squared, that's the only time you get out of the square root, because this 2 cancels away that, and there you are, free. Okay, that's what the square does. The square gets you out of the square root. Okay, it's kind of funny. The square gets you out of the square root. So I'm going to break down 16, right? So I know that 16 is 8 times 2. Okay, now none of these numbers, neither 8 or 2, I don't see any squares. I don't see any repeating numbers. So I continue and I say, okay, well, what is 8? 8 is 4 times 2, and then I have that 2 in there, so I have 8 broke down into 4 times 2, and then times 2 here. So if I continue this, I have 4 times, now 2 times 2 is 2 squared. Okay? What happens now? I said that the square gets the number out of the square root, so this 2 over here can get out of the square root. Only 2 can get out of the square root. The 4 is still prisoner in there. It can't come out. So the 2 comes out. 2. And here we have the 4. Right? And we continue now. So 2 root and 4. What is 4? 4 is 2 times 2, right? So it's 2, 2 squared. So, oh, this other 2 comes out of the square root. So this other 2 cancels the entire thing. It's gone. And comes out, and it's 2 times 2 equals 4. Okay? So that's the way you could break down a problem and come out to the answer. of the square root, step by step. You don't necessarily have to have all these answers on top of your head. Another way to go by 16, you could know that 16 is 4 times 4. You always, if you can find two identical numbers multiplying each other, you can get them out of the square root, right? Why? Because 4 times 4 is what? 4 squared. And what does this guy over here do? It kills that square root and comes out as 4. Right? We don't have to use the word kill, but it cancels it. It erases that square root sign and then comes out free, right? That's what that 2 does. Okay? So this is the method of finding the square root. Okay? And there's plenty different ones, but gotta get used to one. Other roots, right? So what are other roots, right? So we've seen the square root. This symbol stands for square root. So for square root, we know that what we have to answer here is what number squared, gives us the number under the root, right? And I have to, when we have this, let's say this is a number, this is called the number under the root, whatever is in there. Under the root. Whatever is inside here, inside the square root or whatever root we're going to use, is called the number under the root. So when we have square root, we say what number squared gives us the number under the root, right? So that's that. But we have other roots. We have the cube root. Now this 3 over here, right, makes this root the cube root. Okay, if we don't have a 3 there, we automatically assume it's a square root, but this is the cube root. Okay, so the question here is, what number cubed will give us, the number inside? So like if we have 8, right, 8, we're gonna think of this question mark, right? Like what do we think now when we have cube root of 8, right? The first thing we think of is, the first question we think of is, what, right, numbers, so I'm going to say that, what number cubed will give 8? Okay, what number cubed will be 8? Or what number, to the third power, that's what to the third power means, is cubed, will give us 8, right? So I can start trying, I mean, I'll start with low number, right? 1 times 1 times 1 is 1, so that doesn't work, right? So I can look at something like, 2 times 2 times 2. Well, 2 times 2 is 4, right? Times 2 will give us 8, right? So we found the answer here. The answer here is 2. Number 2 multiplied by itself 3 times gives us 8. 2 times 2 times 2 gives 8. So the cube root of 8 is equal to 2. Okay? Because 2 cubed equals 8. And this is the root. This is where it originates. This is called the cube root. Because that's what is this is where 8 comes from. 8 comes from 2 being cubed. So the cube is like the root. Like that's where think of 8 as a plant and 2 as the root of the plant, and that's where it originates from. That's how the cube root exists. Now we have, the fourth root, right? The fourth root. I don't know what to call it. We'll call it the fourth root. And again, let's say I have the fourth root of 16. And I want to find the fourth root of 16. The question is here, what number, right? We'll call it a number like this, to the fourth power is 16, right? So if I have 1 times 1 times 1 times 1, I get 1, so that's not that, right? It's a multiplication. If I have 2 times 2 times 2 times 2, is 2 times 2 is 4, times 2 is 8, times 2 is 16. So yes, the root is 2. What was I going to write? Okay, so that is 2. Okay, so we see that cube roots, square roots, fourth roots, fifth roots, answer one specific question. What number to that power that the root is requesting gives us the number under the root? And we know now what the number under the root is, right? So if we have any root, we call this n here, being any number, and we have a number a here, a is the number under the root. Under the root. So that's is the number under the root. And what we find, the answer that we find, like in our case, for example, this, right? Let me use a different color here. Let's see if we have a different color, green. This number here, right? And this number here, right? These guys are called roots. Right? These are the roots. This is where the number 8 originates from. If I cube it, that's where the number 16 originates from if I put it to the fourth power. We will see examples on the next slide, but this is what the roots mean. Okay? Example 1 is the square root of 64, right? Okay, so square root of 64, there's many ways to do that. So I'm going to start with some way that I think it's cool. Like, okay, right, so I'm looking at 64 and I think, okay, what is 64 divided by? Again, I said if we're not good with multiplications, we can pick any number that we think is suitable. So I'm going to pick 4, okay? So I say, you know, in the corner here, right, I make a little division. I say, okay, I have 4 and I have 64, so 4 goes into 6. Well, 64 is here. Get that? Okay, so 4 goes how many times into 64? 4 into 6, I'll say, 1 time. 4, 24. So 4 goes into 24 6 times, right? So I can break 64 into 4 times 16, right? So what I can do now is if I have something like this, I can split it into separate square roots like this. But don't forget the multiplication sign. So it's root 4 times root 16. Now, root 4, what number squared gives us 4? Well, we know that the number squared gives us 4 by now is 2, right? And then we have root of 16. What number squared gives us 16? So, like, you know, 3 times 3 is 9, right? So 4 times 4 equals 16. So 4 is the answer, right? Then I multiply, so this is the result for this one, and this is 2 times 4 equals 8. So I know now that root of 64 equals 8. That's how I go by doing this problem. Okay, if that was too fast, put it on slow motion. But that's what you do. Okay, so you break down 64. I thought of 4. Somebody else could think of 2. You know, I mean, it depends on how you want to start the problem. It's all up to you. Okay, but I picked 4. 4 times 16, I can make the split happen over here, see? You know, I have 4 here, and I have, you know, the 16 here, you know, and I put them in different roots here, you know, root 4 times root 16, and then I found what the root of 4 is, and I found what the root of 16 is, and that's the answer. Now, let's move on to 256. It's a bigger number, so it's a little bit more more work involved in there. So we have 2 here, we have a root of 256, right? So it's a little bit more difficult, but we can do it. Okay, so again, you know, I'm going to say I have 256, right? So I have a 6 in there, but I'm going to try, you know, I'm going to say, okay, well, let me try divide 256 by 4, you know, because I want to play it safe, you know. How do I know to divide by 4? I don't know. I just picked, and you know, there's a 6 in the back here. 9 times 4 is 36, so you know, there's a possibility it divides by 4. So 425 goes how many times? 6 times. So we have 24 here. 1, right? 5 minus 1, and then we drop the 16, so it's 4 times what gives 16, and 4 times 4, so it's 16. Okay, so now we have, you know, and you can see how things get easier, right? I mean, we have root of 4 times root of 64, right? And now we do what we said we did before, right? We split this. So we say root of 4 times root of 64. And we saw previously that root of 4 is 2. And what is root of 64? Well, we saw in question number 1 here. Let's put it here so we don't... It's 8, right? So it's 8. And this is how you're going to end up remembering things, you know, by being exposed once or twice to these things, you know, you're going to remember what root of 64 is. 2 times 8 is equal to 16. So we know now that root of 256 is equal to 16. Isn't that beautiful? All right, so that's how I'm going to go by doing this problem. Now we have a fraction, right? And fractions are always scary. So we have 25 over 121, but we are not scared. So when we have a fraction, we have the numerator and denominator. So what do? We split it. We do root 25 over root of 121. Okay? So root of 25, a very common one, square root of 25 would be 5, and square root of 121 would be 11. So 5 over 11 is my answer. So that's what you do. That's what you end up doing in this case. You split it. So this big root splits into 1 and 2 little roots, one on top and one on the bottom. You separately do them, and you keep the division bar in between them. So as we can see, it wasn't that scary. We did the cube root of 8. I'm going to go over it again a little bit. The cube root of 8, so we want to find 3 numbers. So we have, 2 times 2 times 2, right? Which is 2 cubed. And see, I made a mistake. I shouldn't forget that 3 over there. So that 3 should always be there, because now this will cancel that out, and the 2 will come out to be free, and he's so happy. I was like super happy. And it comes out to be an eye with a nose. Yeah, see, math could be fun. But anyways, that's what happens in this situation. And then we're going to go to the last one. Okay. Oh, what did I do? And I did something wrong. Okay, the last one is over here. So we have the cube root of 125. Okay. So here we see 125. So again, we're going to start dividing stuff. 125, 5 divided by 5. 5 goes into 12 twice. 10, drop 2, 5 goes into that 25. So we have 25 here, 0. So we can split this cube root as cube root of 5 times cube root of 25, right? And previous to that, it was going to just be like this, 5 times 25, and then we split it like this. Okay. Now we have cube root of 5 times 25 is what? Is 5 times 5. Look at how many 5s we have here. We have 1, 2, 3 5s. How do we group them in 1? We just say this is 5 cubed, because 5 times 5 times 5 equals 5 cubed. We know exponent tells you how many times you're multiplying it. So what does the cube do when we have a cube root? Well, this guy here gets rid of this root thing, and we leave the 5 comes outside just as it is, and we have a happy 5 there. It's free. So that's what happens